Hey guys, this is Miss Katz again, and we are going to be doing the second half of the Unit 5 End of Unit Study Guide. So let's jump right in. We left off at question number 8. So the Audi A7 has 24.5 cubic feet of cargo space. Could the following be dimensions for the cargo space? So what we're really looking for is if I take the volume of these dimensions, will I get 24.5 cubic feet? Let's try it out. So remember, we can't multiply these fractions until or unless we get them into improper fraction format. So let's do that. 2 times 2 is 4, plus 1 is 5. So this becomes 5 halves. 3 times 2 is 6, plus 1, which is 7 halves. And 5 becomes 5 over 1. All right, I do not have any common factors top to bottom, so I cannot simplify before I multiply. So we are simply going to multiply across. I get 175 on the top, and on the bottom I get 4. Now, we need to see if that's equivalent to 24.5. So 175 divided by 4 is equal to 43 and 0.75, so 43 and 3/4. To figure that out on the calculator, the best way to do that, let me just show you. We take 175 divided by 4. That gets you your whole number. Okay, which I don't know if you can see very well, but that's a 43. Okay, so that gets you the whole number that we put right here. And then what we do is we take that 43 times the denominator, which is 4. That got me up to 172. But I needed 175 total. So that leaves 3 left over when I needed 4 to make another whole. Okay, so this is that much feet cubed. So the question is, could the following be the dimensions for the cargo space? The answer is no, because it is too much space. All right, we're going to move on to question number 9. I hope you guys can read this one. Serena has determined that she needs a truck with 800 cubic feet of space or more to move her furniture. Does the truck illustrated have the space that she needs? Okay, so I don't know if you can see this. I hope so, because I can see it, and my eyes are a lot older than yours. But this is 7.5, and this is 15, and this is 7.5. So we just need to figure out the volume. Okay, so the volume, again, equals length times width times height. The volume will equal 7.5 times 15 times 7.5. So let's plug that into my little calculator. 7.5 times 15 times 7.5, that equals 843 and 75 feet cubed. And we needed at least 800 to fit all her belongings. So the question is, does the truck illustrated have what she needs, the space she needs? Yes, it does. Okay. We're going to move on to the next side, which is question number 10. It says the dimensions of 2 boxes are shown in the table. Which box has the greater volume and by how much? All right, so let's get the volumes of each of them, and then we're going to compare them and figure it out. So box A, the volume equals length times width times height, and box B, the volume equals length times width times height. So in the first box, box A, it's going to be 15 times 5.3 times 4. And in this case, I would probably use parentheses to set off my numbers because those dots can get confused with decimal points. So again, let's bust out the calculator, and I apologize for the glare. But it is 15 times 5.3 times 4. So that gets me 318. The volume is 318 centimeters cubed. Let's check the other side now. Okay. So on the other side, the volume is going to be equal to 8.7 times 3.5 times 12. Again, you guys are lucky. You have calculators for this unit. Take advantage of that. Just be really careful when you input the information. And I'm going to just double check it, which is what you should always do, because if you have no frame of reference as to what that number should look like, you want to make sure that the number that you plunged in were correct. All right, so we've got those 2 volumes. Now we want to figure out the difference between them. So we take the bigger one, which we've already got in the calculator, and we subtract the smaller one, which was 318. So the box B is bigger by 47.4 centimeters cubed. All right, let's move on to question number 11. You need to write a situation that would require you to use surface area, and then write one that would require you to use volume. So surface area would be things like wrapping paper, how much wrapping paper you would need, paint on a wall or anything really, carpet, material for clothing, etc. Volume is how much we would stuff inside something. So it could be water to fill a pool, Jolly Ranchers in the container, how much paint in a can, etc. Okay, volume has to do with how much we fill inside. Surface area has to do with how much material we would need to wrap the outside. All right, we want to know what the surface area is of a cube with a side length of 7 yards. So a cube has all the same dimensions. So if it's 7 yards here, it's also going to be 7 yards here, etc. And 7 yards here. So one side, so the area of one side is going to be base times height. In this case, that's going to be 7 times 7, which equals 49. Now, in a cube, all the sides are the same, and there are 6 of them. So to get the total area, we just take 49 times 6. So it'll be 294 yards square. Remember, we've been working a lot on cubes because we've been working with volume, but area is square. All right, let's go ahead and find the surface area for the square pyramid that's listed right here. All right, if it's a square pyramid, then that means that all of the sides are 7 centimeters, which means all the bases of these triangles are 7 centimeters. So we really only have to find 2 areas and then manipulate them. So let's start with the base. The base in a square pyramid is a base, so the area equals base times height. The area equals 7 times 7. The area of the base is 49. Let's do the triangles then. The area equals 1/2 the base times height. So area equals 1/2. The base is 7 still, and the height is 9.1. So this is where I would bust out my calculator. 9.1 times 7. And then to take half of something, remember we divide by 2. So the area of each triangle is 31.85. Now remember, there are 4 of these. So we need to take this area, okay, 31.85 times 4 to get the area of all 4 of those triangles, and then add it to the 49 that we had. 32, that's 34, that's 7, and 12. And remember, we're going to move the decimal 2 places. So we end up getting 127 and 40. And again, just to verify, 127.4. And we're adding that to 49. Please don't forget to line up your decimals. We did that way back when, and you guys should have that down by now. All right, so the grand total surface area here is 176.4 centimeters squared. All right, let's flip over and do the very last problem. Again, we're going to do some surface area. And the nice thing is you've been given all these nets, so you don't really even have to figure out what shapes you're looking at to be able to handle these problems. So a cereal box is in the shape of a rectangular prism. The height of the box is 16 centimeters. The width is 6, and the length is 8. So what is the surface area of the cereal box? So let's take each piece, A, B, C, D, E, and F. And when you find that your dimensions are going to be the same, okay, then you know that they're the same. So if you look, 16 by 8 is this guy right here. And this one is also 16 by 8. So A and C are the same. Okay? E and F are 6 by 8. So E and F are the same. And you'll see that B and D are the same. So we only have to do 3 calculations here and then double them. So for A and C, the formula is area equals base times height. So that equals 16 times 8. And again, you're welcome to do it by hand. But 16 times 8 is 128. Now we have 2 of those. So that's going to be A and C. All right, then for E and F, we've got area equals base times height. That's 6 times 8, which is 48, and we've got 48 here too. And then for B and D, the area will equal base times height. It's going to be 6 times 16 this time. And 6 times 16, 96. And we have 2 of those. All right, so let's just get a grand total. 96 plus 96 plus 48 plus 48, 128, 128. The grand total here is going to be 544 centimeters squared. Again, surface area is squared. Hope you guys prepare well and are ready and you ace your test.